Hello everyone. So today my talk is on competition-based learning. And so some of the key components of competition-based learning include, well, first it starts off with either the teacher presenting a question or some type of problem that is posed to students. And then students are required to create some type of item based on that problem or that question, or the students must work together to solve some type of problem using scientific processes. And so there's a lot of collaborative grouping going on, hopefully, because that is, from what I've read, the best way to utilize competition-based learning in a classroom. There's some collective learning outcomes, such as like if it's a robotics competition, that all of the students collectively work on these projects in small groups, and then everybody presents their robot at the end of the competition. It's curriculum based, so it's aligned to your standards, and the problem should be connected to real life and any challenges that might occur within real life. There's collaborative team processes. All team members must be active participants, and there's usually little help from teachers. So the people within the groups have to know how to maneuver themselves in ways where they can answer some of their own questions, or they can find answers to their own questions using technology, if and only if that is allowed in the competition. Okay, so how does this align with scientific processes? Well, first, there's collaborative groupings that they develop some type of hypothesis, or they're asked a scientific question, and they must use science or scientific processes to draw some kind of conclusion or to find solutions. So there's game-based, where students are asked to solve certain problems, like they may be real-world problems that might happen in their own community or throughout the world. And so the students have to work together to reach some type of conclusions based on scientific evidence. And so they might be given that scientific evidence, or they might have to try to figure out how to collect that evidence. And then sometimes they might have to test some hypothesis. And depending on the way that it's set up, they might or might not need to test these things. Sometimes it's just about, here's a problem. Let me use my scientific processes to try to draw a conclusion based on some type of evidence that I can either collect or is already given to me. And the really cool one is when students are asked to build or design some type of object or thing that can help solve the scientific problem. And so there's collaborative groupings. They develop a hypothesis, or they're asked the scientific question based on what's going on. And then the students have to develop and create some object based on that presented problem to them or their own hypothesis. And so in order to achieve some type of solution or conclusion to the problem or the question, students, they must collect data. They might design something and collect data based on what they've designed. And so then they have to continue testing this design to ensure that it's going to solve the problem that was presented to them. And finally, once they have some kind of final product, they can draw some type of conclusions based on that product. So in this type of competition where there's some kind of building or designing going on, it's 100% real world connected. We see people designing robots or prosthetic arms, wheelchairs, all types of things every day to advance our society. And so this is 100% real world connected. You have to use science processes in order to achieve a final product. You know, you're testing, you're collecting your data, you're drawing conclusions. You might have to go back and test some more. And so you're using a lot of scientific processes. And it's very related to the real world and how competitive it is on our global economy. One team might make something that goes faster, while another team might make something that goes slower, but the need is for the object to go faster. And so who's going to win? It's going to be the team that has the fastest design for the cheapest cost. And so it's very related to how our economy is set up. So there's some benefits. Students become stewards of their own learning. This is very engaging. Students become very active participants. Like, nobody can lay down on the job because you're going to need everybody in the group to participate in order to achieve the end. It promotes problem solving, communication amongst peers. It establishes a social network and improves the social network that the kids have in the class and amongst their peers and their teachers. And it improves planning skills, because it's going to be, and organizational skills too, because there's a process that must go on in order to achieve a final product. It also provides an opportunity for real-world connections and competitive level work that you might see out in the real world. It develops hidden talents and strengths amongst the learners. There are some kids that are have a talent or a love for designing things, and so when you put this in front of their face and they get to use their educational knowledge, whether it's science or math or even English, what happens is they're given an opportunity to only enhance and bring upon their talents into the classroom. It also allows some building or designing a product, allows for all of your other disciplines to come into play. And so you're going to sometimes be forced to use math within science, and sometimes you're going to have to use engineering within science, or science to help you with this engineering. And so it requires all of these disciplines to work together, and it also enhances each of these in some aspect. There are some limitations. Cost might be one of them. If you decided that you wanted to do a robotics competition in your classroom, you're going to need some money, and so this may present some problems. Differentiated lessons or grouping might be required based upon the needs of your students. There are some classrooms where children function at a lower level in certain aspects of education. It might be math or it might be science, and so they might need more assistance and maybe somebody who's stronger in that area to assist them. And so in order for all students to be able to achieve the final product and to actually enjoy the lesson, sometimes we're going to have to differentiate those lessons based on our students' needs. It's also sometimes time consuming, depending on what your final product is. And so we have to take into account that as well. The lesson and assessment must be aligned to the standards. As I was reading, I read that one of the biggest setbacks is sometimes kids get so engaged in the competition themselves, they forget what's really supposed to be going on in some type of scientific learning. And so they forget it because they're so competitive. Sometimes it also causes a lot of stress or hyper competitiveness amongst members, and so that also leads to tension in groups. And so the teacher has to be aware of the communication that's going on within the group context. And then sometimes students lack background knowledge, and so depending on where your students are, you may have to scaffold in order to make the competition itself successful for all of the students. So some really cool examples that I found, the Science Olympiad. If you're interested in this, you could go to their website and look up sample events, and under each one they actually give you what's going on in each of these events. And so you can actually use these for your own classroom, or you can give these to some of your peers, but they have some really cool examples on Science Olympiad. And there's different things. They have to, in some cases, they might build something like the building of a bridge. And at the end, whoever's bridge is stronger or can hold a certain amount of objects, depending on its mass, they're the winners. And so they have a lot of really great examples on Science Olympiad. Another example is NASA has all these robotic competitions. And so some of these are pretty massive and some are smaller that you could actually use within your own classrooms or your own schools. But robotics is real big with competitions. And then on the NSTA page, they also have some great examples of competition-based learning where there's one where it presents a challenge to students to find problems within their own communities, and that the students must use the scientific practices to actually solve the problem, which actually promotes becoming a steward of your own learning and your own community. And so these are just other great examples of competition-based learning. Wow, okay. So if you have any questions, feel free to put them in your replies or your text box, whatever they are, and I'll be glad to answer them. Have a great day.